I'm going to continue with another example of function composition. This one is pretty similar to the ones before. It will be the third one. And here we have again one function with g of x, and we're going to compose it with itself, which is the statement here. It will be right at g of x. Now, here's the 4 steps just to I recommend you to follow in order to get to find the composite function and the domain, which is as well a goal here. So let's start with it. Here's the first step: find the domain of the input function. In this case, it's itself, g, which is the one here, and we have to find which restriction this statement places to the domain. In this case, we have quotients. In other words, we have to look for what's in the denominator in here, and this x plus 2 would have to be different from 0 in order to avoid an undefined situation. So x would be different from -2. In other words, the domain of g will be all the real numbers except for the -2. Okay, so this we just go along with the first step here, and let's go to the second one, which is finding the composite function. Okay, let's get to it here. I'm going to sign in here. We go along with this one. Okay, so in other words, we're saying that g, we're going to substitute, which is actually g in itself. We're going to substitute x plus 1 over x plus 2 in every x of g. So I'm going to do it in here. I'm going to write it here, following the same colors. X. Right here. Here we have a plus 1, and here we have a plus 2. Now, notice something. This part of the expression is actually corresponding with this x on g. And this one here below is the one that corresponds to this x here. Okay, so let's continue now. This would be, in order to get along with this expression, I'm going to have to, do this algebra here to add these rational expressions. So I will have to multiply, in this case, the 1 in the denominator by this x plus 2. Sorry. Yes, there. I'm going to do pretty much the same thing in the denominator here, but with this positive 2. 2 times x plus 2 over x plus 2. And then I will just get to this simplified expression, which would be like this in the denominator, and here below, this is too ugly, sorry, like this. And okay, these two will have to multiply this x plus 2 as well. So I'm going to do that in one step in order to save space here. Just notice I'm going to do 2 times this x plus 2 times this positive 2 here. Will be here 4, and then we'll get here and the x plus 2 below. So I can just write it like here. I'm going to get them together as they now share the same denominator in here and in here. We can just pretty much get them together now easily. Here will be x plus 2. Here will be x plus 1 plus x plus 2 all over x plus 1, 2 times x plus 4 over x plus 2. Now here I'm running out of space, so I'm going to continue in here. Now let's see, we get to this statement would be here 2 times x plus 3 over x plus 2 over 3 times x plus 5 over x plus 2. Now, in order to get along here, now here we can simplify things out, just going to do it all the way. I'm going to use the super famous sandwich rule here, and then we go to this fine expression. It will be 2 times x plus 3 times x plus 2 all over 3 times x plus 5 times x plus 2. Now here we can simplify things out. This one goes out, this one goes out, and now we got finally to our composite function. I'm going to continue here just to make it clearer what I'm doing. It will be 2 times x plus 3 over 3 times x plus 5, and okay, I'm just going to sign, I'm going from here to here, and this actually would be our composite function, which is g of g of x. Now, by doing so, we just got along with the second step here. And now we have to proceed to do the third step, which is find the domain of the composite function. So here I'm going to use, well, it's pretty similar to the, actually, with the one we just did, this one here. So we have to do pretty much the same thing. We got to look for what's in the denominator, as this is a rational expression, and we just write it like this: 3 times x plus 5 has to be different from 0, so 3 times x has to be different from negative 5, so x has to be different from negative 5 over 3. In other words, the domain of this expression, which I'm going to call g of g, just to make it clear which domain I'm talking about, will be all the real numbers except for negative 5/3. Now, this is we go to along with the third step, finding the domain of the composite function. Now here comes the thing: we have to, in order to write the whole solution, we have to take in consideration both of the domains we got from the input function g of x, which is this domain here, and as well the domain of the composite function here, this one here. So the final domain would be all the real numbers except for 5/3 and negative 2. Well, actually, I should write it properly. It would be here a negative 2 and 5/3 here, and that will be the final domain. Now we got here our g of x, and we got our domain, and then that will mean that we are done.